Good afternoon. We're going to go ahead and get started. Welcome to the 2025 Directors Award Ceremony. Before Mike formally welcomes all of you, I want to share a few housekeeping and safety items with you. This is a hybrid ceremony and the session is being recorded. We have enabled live captions for those of you who are joining us online, and for our Zoom audience, we will be able to participate and share their congratulations via chat. And for safety, and since this is for some the first time that you've been in this space, and I see we do have some children. Thank you for being here, Clarissa and others. Welcome. We don't have candy, but that's probably don't want to do that. Now I've lost my place. Let's replace ourselves, refresh ourselves on the exits and the evacuation routes for this auditorium. In the event of an emergency, please exit via the stairs, out the doors, and across the parking lot, and emergency personnel will direct you from there. And when it's safe to return, they will direct us back into the facility. Now, without further ado, I'll turn the proceedings over to Director Mike Witherall.
So, thank you. Boy, this is a big crowd, and people come earlier for this event than anything else we do, which is to say what a highlight of the year it is for us. It's a really a joy to celebrate the accomplishments of many of our colleagues and have a chance for us to celebrate together what we do together. So I want to make a special welcome to the friends and families of the awardees who are here with us for this event. As Michael pointed out, we appreciate your support, and we know that your family members could not do the work here they do without you, without your support. So I'm going to start today we have two really important teams to recognize, since we are the home of team science, that are so large that even this auditorium was not big enough. And so we've had, as with the Academy Awards, we've had some pre-awards and I'm going to take this opportunity to talk about what they have done. The first is for the bioepic team. And of course, that's a very visible one as we see that building that I go past every day. When the lab undertakes the construction of a new building, the project requires years of designing, planning, and budgeting, and a lot of work with Washington, D.C. to make sure that we actually get funding for it, which is sort of where I came into this particular project. And everybody plays vital roles in bringing this complex facility to fruition. So this new building, called the Biological Environmental Program Integration Center, or bioepic, will enable new science and technology by bringing together programs from both biosciences and earth and environmental sciences. And together, these researchers will use microbes and plants to unlock the potential for solving urgent environmental, water, and energy challenges. We believe it will be the place where we discover innovative new technologies to advance ecosystem science. It also has the greenhouse with the best view, by the way. If people notice it, it's the roof, the penthouse greenhouse, as we say. And what examples of the team's early success? The building's innovative construction recently earned its LEED Gold certification and an Excellence in Sustainability Award of Merit from the Engineering News Record. So for this one, for everybody to be safe, we're going to ask the members of this team who are present to stand up so we can see you. So please. And as you can see, there are many more. And I really want to say this is some of the most important work we do, our teams like this. We have one more team that I'd like to now bring forward. So this is our the secretary visit team. That was actually another all lab effort. We hosted the newly confirmed Energy Secretary, Chris Wright. This was a big day for the lab, and it went fantastically well. It was critical that we demonstrate the importance of the labs, and we are talking for all the labs because this was very early in his time, as well as our unique capabilities here at Berkeley. We also had this wonderful opportunity to announce the Dell NVIDIA partnership for NERSC 10, and that the new supercomputer would be named Doudna. Visit went very smoothly. I will say we had a meeting with the secretary where Jennifer Doudna was there talking about how important the lab was in development of her career. And then about when she was done, Jensen Huang came in from NVIDIA and talked about how important their NVIDIA's work was here. So that's pretty good for the Secretary of Energy to hear in his first few days about us. So all of this success was a result of weeks of planning by over 200 people. It started planning before we had any idea what the date was going to be, I mean, to give you some idea. Every scientific area, nearly every operations division was involved in planning, logistics, presentations, or behind the scenes support, and everybody worked together and showed the lab at its best. I will say when it was about 10 days later, all the lab directors were in Washington talking to the secretary and his chief of staff, Carl Coe, and he basically said, I knew the labs were great, but after that visit to the labs on the West Coast and seeing what they did, I now really understand how important this is. So it really made an impression on me. So once again, here is the group. Here's the sort of the memories of the day. But I'd also like everybody who was part of this team to stand up to see you, so we can see you. So for all the people that are here. And we only had one child standing up there. I'd now like to pass this on to Natalie Rowe, who's going to bring up the first people onto the stage. So Natalie, take it away.
All right, well, thank you, Mike. I'm very pleased to present the Director's Award for Exceptional Achievement in Early Scientific Career, which is designed to foster the next generation of scientific discovery. And this award category recognizes scientists early in their careers, typically within 10 years of their PhD, who have made substantial contributions leading to important progress in an area of research or completion of a project. And the first awardee in this category is Jose Luis Rideros Fernandez. Jose is a research scientist in the Accelerator Technology and Applied Physics Division. He was nominated by Cameron Geddes, the division director. Jose invented the unilayer magnet, a breakthrough that achieves higher fields with less costly superconducting material, making future colliders more affordable. Jose also pioneered a method to reduce or eliminate the time-consuming training process in superconducting magnet development, and led tooling development for the test facility dipole, which is Berkeley Labs' contribution to a world-leading facility supporting DOE's fusion energy sciences and high-energy physics missions. And beyond these achievements, Jose devotes time to educating and inspiring the next generation of scientists while advancing the lab's leadership in technologies for future particle accelerators. So now, Jose, please join me on stage. All righty. The next awardee in this category is Timon Heim. Timon is a staff scientist in the physics division, and he was nominated for this award by Simone Pagangriso. Timon has played a pivotal role in upgrading the magnetic tracker for the ALICE experiment on the Large Hadron Collider, which is an international effort involving over 100 institutions worldwide. Timon is the only member of the over 3,000 person collaboration with major deliverables for both the precision pixel layers and the large area silicon microstrip tracker, while also leading R&D at Berkeley to push detector technologies beyond the state of the art. As a dedicated mentor, he also guides younger colleagues in advanced instrumentation. Over the past decade, Timon has been a driving force for progress and innovation, helping to unlock new fundamental physics at the world's most powerful particle collider. Timon, would you please join me on stage? Okay, and now I'd like to invite Marianne Piet for the next Early Career Award presentation.
Thanks, Natalie. This is such a pleasure. This is one of the best days of the year here at the lab. I have the pleasure of introducing Marco Pertoni. Marco is a staff scientist in the Building Technology and Urban Systems Division, and he is another of our early scientific career awardees. He was nominated by Michael Vetter, and Marco led the development and demonstration of standardization of semantic models that enhance interoperability in smart building systems, enabling AI-ready data sets, as we all are thinking a lot about these days. That also enables energy savings and grid support, and his work has driven international collaboration through a multi-lab effort, helping establish an industry-wide standard called Design and Classification of Semantic Tags for Building Data. These achievements have cemented Berkeley Lab's position as a global leader in the field, paving the way for partnerships that bring science solutions to the world. Marco, please join me on stage. And now I'd like to introduce Susanna Tringe for the next award.
Hi, I'm excited to have the opportunity to honor Katerina Zhalnina, who is a research scientist in environmental genomics and systems biology. I nominated Kate myself, and noting that she's developed innovative strategies to characterize how microbes can contribute to plant and environmental health, and opened a new field of inquiry into how plants recruit beneficial microbes to boost yields and reduce greenhouse gas emissions. Kate also played a key role in implementing the ecopods, large plant growth chambers that enable realistic, reproducible plant microbe experiments, advancing the biosciences area's strategic goals, as well as a new capability in BioEpic, our new building that was shown earlier. Her research has been extensively cited across multiple scientific disciplines, highlighting its outsized impact and marking her as an emerging leader among her peers. Kate, would you join me on stage? And next, I'd like to invite Alistair Rogers to come up on stage for the next.
The final awardee in this category is Michelle Newcomer. She's a research scientist in the Climate and Ecosystem Sciences Division. I nominated Michelle for the award because of her exceptional research that examines the impact of compounding wildfire and drought, shifting precipitation patterns, and post-fire watershed functioning. Michelle integrates microbiology and biogeochemistry with landscape-scale watershed characteristics. She's advanced our understanding of watershed wildfire dynamics and mountainous hydroclimates. Her work has informed DOE and interagency priorities and is transforming how these critical systems are managed. Her work has firmly established Michelle as a rising leader in this field. Michelle, would you like to join me on stage? Please, could you join me in thanking all of the early career awards? This next category is mentorship. And this award category recognizes significant efforts to foster a sense of belonging and an access to opportunities for career advancement among employees, regardless of their backgrounds. We have two awardees in this category. The first award in the mentorship category goes to Bill Riley. He's a senior scientist in ESA and was nominated by Junyun Tang. For 25 years, Bill has been an exceptional mentor, engaging mentees at eye level and nurturing their scientific vision and independence. His generosity, time, inclusive approach, and ability to unite disciplines have made him a sought-after advisor for researchers worldwide. Bill has mentored over 40 early career researchers, with dozens of his mentees and former advisees holding permanent research positions around the world, including 4 career scientists at Berkeley Lab. Bill's influence has also significantly impacted the scientific field of ecosystem modeling, and his science has helped prepare the division for AI and machine learning and shown what true team science can achieve. Bill, will you join me on stage? And I'd now like to invite Paul Adams to take over.
Okay. Thank you, Alistair. And it's my great pleasure to introduce our next awardee, who is Junelle Tamara Basso. She's a research scientist the Joint Genome Institute in the biosciences area. She was nominated by Hee-Jung Cho in recognition of her exceptional mentorship work that has propelled the careers of scientists at every stage, from high school students to postdocs. She's supported mentees through lab work, presentations, and writing. She actively fosters collaborations, organizes key networking events, and passionately advocates for a supportive and collaborative scientific community. Her resilience and innovation, notably adapting wet lab training during COVID, you might remember that, exemplifies her commitment. She really wanted to see the research carry on even during that time. Janelle's global outreach, operational problem solving, and proactive leadership in fostering collaborative scientific communities have advanced the lab's mission, strengthened its community, and inspired the next generation of diverse scientific leaders. Janelle, please join me on the stage. And so please join me in thanking her. Clearly, a lot of you know Janelle. Okay, for the next award category, I'd like to invite Natalie Rowe back onto the stage.
Okay, thank you very much, Paul. In addition to presenting the Directors Awards today, we'd also like to recognize 4 lab scientists who have been honored with this year's prestigious Early Career Research Program Award. These awards come from the Department of Energy's Office of Science to recognize exceptional contributions in R&D that support the DOE and its mission, and come with almost $3 million in funding over 5 years. And I'd like to take a moment to tell you about the incredible projects that they're going to be able to work on in the next few years because of this support. First is Dan Carney. Dan is a staff scientist in the physics division who uses quantum information science to study particle physics and gravity. That sounds pretty amazing, doesn't it? At very small scales, quantum noise originating from the uncertainty principle can drown out faint signals from rare processes. Dan's ECRP project aims to build a new mechanical quantum sensor that can measure extremely small particle interactions below the limits of that quantum noise. The approach uses lasers to hold a tiny bead containing radioactive atoms, and when one decays, the system measures the bead's motion and the energy of the particles emitted. The experiment's initial goal is to search for heavy, sterile neutrinos, hypothetical particles, predicted by some extensions of the standard model of particle physics. The system could also help measure the mass of the neutrino, study the way particles interact through the electromagnetic and weak forces, and hunt for low-mass dark matter, all unsolved mysteries of particle physics. So congratulations, Dan. The second Early Career Award has been awarded to Timon Heim, who was just awarded with a LBL Early Career Award. Timon is a staff scientist in the physics division, and his ECRP project will develop a new type of detector that can track the particles generated by collisions in particle colliders with both high spatial and high temporal resolution, so-called a 4D tracking detector. Current detectors in use at high energy colliders, like the ATLAS detector at CERN, the trajectory and measure the momentum, but they can't track a particle's time of arrival with sufficient precision to discern from which of the many particle interactions they originate. Timon's proposed new technology aims to solve this challenge by developing custom microelectronics that process the signal in the silicon pixel sensor, allowing researchers to glean more precise data from collision experiments to uncover new insights into fundamental forces and potentially discover new particles. The enhanced capabilities of such a 4D tracking detector will be a necessity for experiments at future colliders with higher energies and higher interaction rates. So let's congratulate Timon on his award. And the third award goes to Harrison Elizabeth. Harrison is a research scientist in the Energy Geosciences Division focused on combining real-world experiments with AI to guide development of geothermal energy systems. In his project, he will explore how deep underground rock formations are stressed by chemical reactions of the minerals and mechanical strain from movements in the earth. A better understanding of subsurface stresses is essential to engineer safe and reliable geothermal wells that access the heat of deep rocks to produce electricity. Harrison will develop machine learning models to predict geologic strain based on field measurements and help refine existing models that describe how common rock types deform under stress. With this project, Harrison hopes to develop a framework to predict stress to improve the stability and longevity of geothermal wells, and it is estimated the U.S. could generate 10 times the amount of energy needed to power the grid just using geothermal sources. So obviously there's a lot to be gained here. So congratulations to Harrison. And finally, the fourth goes to Callum Wilkinson. And I just want to take a moment and recognize that there have been 3 DOE Early Career Awards in the Physics Division this year, which is really unprecedented. And it really is a testament to the outstanding staff there. Callum is a staff scientist in the Physics Division who works on the International Deep Underground Neutrino Experiment, DUNE, hosted at the Berkeley National Laboratory in Illinois. DUNE will measure an intense beam of neutrinos as they pass through near-site detectors at Fermilab and then continue for 800 miles through the Earth until they pass through massive far-site detectors in an underground lab in South Dakota. By measuring how neutrinos change during this long voyage, researchers will get a better understanding of their fundamental properties and whether they are responsible for why there is so much more matter than antimatter in the universe, and hence why we exist. Callum's ECRP project will apply machine learning techniques to improve analysis of DUNE's data and enhance the experiment's precision by looking for hidden patterns in how neutrinos interact, and also by correcting for distortions in the data the detectors record. And these methods will first be tested on one of DUNE's prototype detectors to validate the approach and demonstrate its power to sharpen DUNE's sensitivity. So congratulations to Callum, and let's also recognize all 4. And let's see, at this point, I'd like to invite all 4, if they're here, to come on stage. All right, and for the next award, Mike, would you please come back to the stage?
So again, thank you. This year, we only have one Lifetime Achievement Award, but it's a really important one. And that's to Kevin Einsweiler. So Kevin was nominated by Carl Haber. He's someone who I've known his work throughout his career, internationally recognized physicist, and his career really, the use of proton-proton or antiproton interactions, what we call Hadron-Collider physics, he's been there from the beginning until today. He began with the CERN Fellowship at the UA2 experiment, of course, came here to Berkeley, was importantly part of the Atlas Pixel project for the Atlas at CERN, and did a lot of the work leading to the Higgs boson discovery. But the good thing is you don't have to hear me talk about this because we have a video, which does it in a much more entertaining way. So what I'm going to do is get out of the way, and they're going to show a video to show you can really see everything he's done and hear from the people who work with him. So cue the video.
I graduated from high school at 16. I went to the University of Minnesota. A bunch of us would go off to Fermilab and would work for a week or something and then come back. And I just thought all of this was so amazing that I didn't ever want to do anything else.
Kevin Einsweiler is an outstanding scientist who clearly enjoys a high reputation in the experimental collaborations he worked in, largely UA2, but also CDF, and of course the Atlas experiment.
One of my main reasons for choosing to come to Berkeley, and I wanted to be able to work with George Trilling and Gil Gilcrease. I was the physics coordinator, and Gil was the technical coordinator, and George was the spokesperson. It was just a remarkable experience.
He's among the best in the world in every aspect. I think he was viewed as being this whiz in doing data analysis. And in the end, he was the whiz at doing the opposite side, the most instrumental side. And that's what I think makes him so extraordinary. He's really quite amazing.
You know, I've known Kevin for almost 40 years. He was instrumental in developing the Berkeley role in the Large Hadron Collider.
We wanted to make something that we knew would be much better and that would allow us to go even to higher luminosities than we dreamed of in 1994.
Kevin had a very important role in the analysis aspects of finding the Higgs boson, which was the most important result from the LHC, clearly.
My first encounter with him, I was trying to find my way. I essentially crashed on another person coming from the other corridor, and I told myself, who is this person, the only one who is working at 1 a.m. in the lab, and that was Kevin. I'm missing our chats about physics, about the future of the field.
Working with Kevin can be demanding. After some time, you have to follow his pace. This was also part of the success story for the Pixel installation and commissioning.
He was in charge of the initial integrated circuit development for the pixel detector, which was very hard. What made him unique was, okay, well, here's this really, really hard technical problem, and I have had no experience whatsoever, none, in this area, but I'm going to learn how to do it. Not only to learn how to do it, he led how to do it eventually.
We were in the middle of trying to define an upgrade to try to come up with a better atlas. I decided I would go for upgrade coordinator, where I had to really systematically understand all of the things we planned to build for this next generation, which will only start running now in 2030.
We used to have an office at CERN for all of the Berkeley group, and Kevin had a desk there, and the desk was always piled high with stuff to read. The rest of us, you know, we read stuff and so on, and there was, you know, maybe a coffee cup and a paper on the desk, but his was just like, it was literally like, you know, a foot high or 2 feet high.
Overall, I think it is also fair to say that Kevin shaped to a large extent the detector, but also the physics of the Atlas experiment.
I think it is especially thanks to Kevin that the LBL experimental program in high energy physics has maintained its position as likely the best high energy group in the US.
What makes these kinds of things work is that we're all kind of driven. Everybody's heart is in it. Everybody gets just excited. Wow, it works like this. Oh, that's amazing.
Personally, I've just benefited from his example, his counsel, his ideas, his insights, his opinions. I've had, countless discussions with him. It's hard to imagine how we could be where we are today without Kevin's contributions.
To me, it's the most fulfilling work that I can imagine.
So it really is that impressive. So Kevin, would you like to come up?
Okay, thank you, Mike. The award committee and Berkeley Lab for this great honor. 35 years ago, I was hired as a divisional fellow in the physics division. I was fortunate to work with many brilliant physicists, among them my two mentors, George Trilling and Gil Gilcrease. Together, we worked on the SDC experiment, and then I continued to work with Gil for many years in the Atlas experiment at the Large Hadron Collider. Thank you, Gil, for your support all those years. And George, you are sorely missed. I'm very grateful to Berkeley Lab for giving me the opportunity to work on so many challenging projects, for the very talented teams I worked with from the engineering division, and to allow me to be on location at CERN for several years to fulfill important leadership roles in the Atlas experiment. Thank you to all the physics division directors for their support during my long career at LBNL, Piero Donne for hiring me, Bob Kahn for insightful conversations, Jim Segrist, Natalie Rowe, and Nathalie Palanque-Debris. Most of all, I want to thank my family, my wife, Sandra, who's a particle physicist at the lab, and our two daughters, Louisa and Julia, for moving across the world and for their love and patience through all the years of my travels and late nights. Thank you again for this great honor.
Okay, now for something somewhat different. So first of all, thank you, Kevin, for all your contributions. Now we're going to have the American Chemical Society has a word. So I'm going to bring up Michael O'Neill from the American Chemical Society, who's going to talk about two historic presentations about the laboratory. So Michael, you can take it from here.
Thank you very much. It's very intimidating to be in such august company, so allow a chemist to speak for just a few moments. I represent the Division of the History of Chemistry of the American Chemical Society. We're one of the largest societies in the world, and the Division of the History of Chemistry is over 100 years old. Back in 2006, we started giving citations for what we consider to be breakthrough awards for science that has advanced chemistry in a profound and extraordinary way. We can just look at one part here on this slide. We look back, we take the long view. And so we look back at least 25 years for something that has happened. And unlike the previous awards, which have been given this afternoon, this award is for the lab. This award is for the culture and the direction and the camaraderie and the genuine genius of this place that we admire as chemists in the American Chemical Society, especially the Division of the History of Chemistry. If I can have the next slide, please. We have an awards committee which consists of friends of Berkeley Lab 2, especially Harry Gray, as well as other historians of chemistry who also, again, look back in time. So next slide, please. I want to give you an example of the company that you're in. So I regret to say, of course, that Professor Watson has passed away, but this particular literal plaque, it hangs at Cambridge University in their Department of Molecular Biology to honor this wonderful and this historic document of the double helix. Next slide, please. This is closer to the University of Rochester, where I happen to have some connection. This is at the University of New York at Stony Brook. This is the first nuclear magnetic resonance paper. So that hangs in New York State. The next slide, please. This one is particularly interesting as well. This is an 1869 paper by someone you may have heard of, Mendeleev. This is in Die Zeitschrift für Chemie or something like that. And this hangs now in Russia at the St. Petersburg State University. That's its physical location. And you'll notice that this, everybody loves this, that Mendeleev is spelled in the schöne Deutsche manner, which is Mendeleev. So if we could have the next slide, please. The two citations which are now going to hang proudly at Lawrence Berkeley National Laboratory, 2 this year. So consider yourselves part of history. The first one that all of us know, but I want to point out something specific, that Ernesto Lawrence's citation here is from his patent in 1934. So it's US patent 1,948,384, which describes specifically a method and apparatus for the acceleration of ions. There is no more modest description of a cyclotron. And I want to also remind you that if you go out on Telegraph Avenue and you need a PET scan, there's an automatic chemical analyzer and machine which synthesizes fluorine 18 deoxyglucose. Glucose is a cyclohexane with 5 hydroxyls if you're in a chemical mood, and one of them is replaced with a fluorine. And there, in that machine, Ernesto Lawrence himself would recognize a cyclotron, which generates fluorine 18 from fluorine 19, which is in the stannous fluoride of your toothpaste this morning. And it has a lifetime of about 109 minutes. That's its half-life. You press a button and you get 100 ml of this stuff. You inject it into a patient and you do a PET scan. And those are the images that you've seen where the brain lights up here, there, and the next place. That chemistry, and it is chemistry, was created by this patent in 1934, which is extraordinary, astonishing. It's still alive, and it's because of this laboratory. And the second one, notice this is Glenn Seaborg's exceedingly famous 1946 paper of the transuranium elements, of which he hadn't discovered all of them yet. He had discovered 10 in his lifetime. There were only 2 or 3 in 1946. But look at this document specifically. Let me actually take a look at my notes here. This is in Science, the journal Science from 1946. And Professor Seaborg, a chemist, chose to put a diagram in this specific paper. And it's not a radionuclide. It's not a nucleus. It's not the description of an atom. He wasn't especially interested in the nucleus because he's a chemist. But what he did show is what he also talked about in 1996 at Argonne National Laboratory is one of the achievements he was most proud of. And you'll notice that this diagram consists of a microscope and a syringe and a plate. And what did he do? He was able to identify for the first time in 1946 a method for microgram quantitation of precipitates in chemical reactions associated with transuranic elements. So chemistry lives, and for the young people in the audience, it's not just physics, pay attention to chemistry. And again, the American Chemical Society's division of the history of science, or history of chemistry specifically, it is very broad, honors Lawrence Berkeley National Laboratory with 2 plaques. And I would like to offer them to your director.
Okay, well, so we've heard some about science, and Mike mentioned team science. It does take all of us working together. So this next category is about, we have a number of awards for organizational impact. And the Director's Award for Exceptional Achievement for Organizational Impact recognizes outstanding accomplishments in support of the lab's mission and strategic goals by enhancing processes, cross-functional partnerships and collaboration, efficiency, and policy implementation. So the first award honors Kirsten Fagan, a computer systems manager in biosciences. Her nomination was submitted by Daniela Kessel for recognizing a critical barrier in DOE's biological research, and that is where world-class data sets were siloed in disconnected systems and scattered across various labs and programs, preventing scientists from connecting, integrating, and reusing the data at the scale needed. Her work transforms disconnected data sets into connected, usable resources that serve as the building blocks for collaboration, automation, and AI-powered discovery across the DOE. These systems enable scientists to reuse data, share analysis pipelines, and pose more complex questions than ever before. She has provided steady, visionary leadership in her work that advances discovery and amplifies the return on federal research investment. Kirsten, would you please join me on stage? The second award in this category goes to Leila Cote, who works in the lab directorate, and she was nominated by Brianna Wright. Layla's work has contributed to shaping the next generation of researchers. She has helped secure over $5 million in grant funding for workplace development programs and has been a champion of these initiatives across the lab to support our workforce development goals. This year, she successfully integrated interns from Navajo Tech into the workforce development programs, opening up the scientific career possibilities for a new cohort. I'm sure her inspiring work in this area will continue to bring new scholars to the lab. Layla, will you please join me on stage? Okay. Next, I'd like to present a team award for outstanding work done to design and implement the first National Lab Research Slam. Over the past few years, the 9-member National Lab Slam team has transformed a postdoc-led communication event into a powerhouse national reach. Their work has been nominated today by Sinead Griffin, who wrote that the team helped turn hundreds of early career scientists into skilled communicators who can effectively share the research conducted at their labs with a wide audience. The exponential growth of the National Lab Slam was only possible through this team's careful planning and tight coordination with other institutions. The annual event has become a staple of science communication, showcasing the range of research conducted at the national labs to federal lawmakers while offering a national stage for our postdocs to engage with the public. The outreach effort has been singled out and lauded in DOE reviews, which is high praise indeed. So I'd like to invite the National Lab Slam team members to join me on stage. Clarissa Bargava, with or without a child. Faith Dukes, Kevin Grifford Tinker, Laurel Kellner, Linda Louie, Jonathan Nurse, Justin Placentia, Meg Rodriguez, and Marilyn Sargent. Okay, the final award in this category goes to Rangina Basir, who is the Health Services Clinical Manager in the Environmental Safety and Health Division. Kelsey Miller submitted this nomination to recognize how her leadership and dedication to the lab's mission has transformed the health services organization. She has improved the quality and efficiency of patient care and prioritized wellness and safety for all employees. Rangina has enhanced the lab's reputation through 2 separate accreditation audits for the lab over the last 12 months. Her work in the much improved health services organization has received recognition for the lab from the American Red Cross and the American Board for Occupational Health Nurses. So, Rangina, will you please join me on stage? Okay, and now I'd like to ask Peter Nico to present the next award.
Thank you, Michael. So the Outreach Award is given to honor significant efforts to increase current and future workforce at the lab. So this year, I'm pleased to present the award to Harry Elizabeth, who is a research scientist within the Energy Geosciences Division. His nomination comes from Benjamin Gilbert. Harry joined the lab in 2019, and since then has led exceptional outreach efforts that have shaped student trajectories and advanced the lab's mission. Harry leads and contributes to an extraordinary number of outreach efforts, both in the EGD division and at the ALS. He has mentored at least 10 undergraduate and graduate students and trained dozens more in his relatively short time at the lab, while also finding time to win an early career award. His success can be measured in the many students who come here because of his outreach efforts. So between bringing new research to the lab, fostering collaborations, leading field trips to look at rocks, or hosting the Secretary of Energy to look at microtomography images of rocks with VR goggles, Harry's activities really embody leadership and team science at the lab. Barry, please join me on that stage. And now I'd like to ask Jonathan Carter to come up for the next.
Thank you, Peter. Good afternoon. I'm honored to present the Societal Impact Awards. These awards recognize outstanding research that furthers solutions to significant social problems or has meaningfully improved the world. There are two teams that we are recognizing today. The first team was nominated by Tom Kerstetter and goes to the Data Center Analysis team, which delivered a landmark assessment of US data center energy use in their 2024 US Data Center Energy Usage Report. This team's research directly informed federal action, shaped public discourse, and established Berkeley Lab as a trusted authority on one of today's most urgent energy challenges. This drew on decades of research and the strongest available data sets to reveal urgent trends driven by AI workloads. They estimated that data center electricity demand could reach a whopping 6 to 12% of US electricity use by 2028. This team amplified the report's impact through more than 50 briefings and interviews with DOE leadership, US House Bipartisan AI Task Force, International Energy Agency, the National Academies, and major media. The team's work influenced national and state legislation, DOE priorities, and global energy modeling. It also elevated the lab's visibility as a trusted national resource for science-based policy guidance on energy and digital infrastructure. The team's effort exemplifies Berkeley Lab's public service mission with our ability to deliver transformative insights that support national priorities. I'd like to invite the members of the team to join me on stage as I call out your names. Arman Shihobi, Sarah Smith, Alex Hubbard, Alex Newkirk, Noah Lay, Billy Malloy Halicek, Eric Massenet, and Dale Sarter. Congratulations, everyone. The second team to receive an award in this category was nominated by Jianzhen Hong, and it goes to the EMIS research team. For decades, this team has worked to develop energy management and information systems from an unproven emerging technology into a trusted, widely adopted solution, delivering measurable energy and cost savings to large commercial buildings. They did this by defining EMIS capabilities and developing national best practice toolkits. They also curated the largest open data set of HVAC operations, and they advanced monitoring-based commissioning and enabled innovation and large-scale implementation. Their knowledge and collaboration have helped the team to become preeminent in this field. The team's work has shaped 2025 LEED rating system, been adopted by multiple US utilities, and set standards for advanced measurement and verification techniques. Recognized across the building industry, the EMIS team exemplifies the lab mission to deliver solutions for science and for humankind. I'd like to invite the members of the team to join me on stage. Jessica Granderson, Armando Casillas, Elliot Crow, Stacy Curry, Reverti Teshipande, Sam Fernandez, Nora Hart, Nathan McKenzie, Ashley Papakiriakou. Now I'd like to invite Marianne Piet to come onto the stage once again to present the next award.
Thank you, Jonathan. This next category honors exemplary efforts in entrepreneurship and building relationships with industry or intellectual property achievements that have an impact on society's health and economy. And I get to present two awards today. The first one is to recognize the Cradle to Commerce team. The Cradle to Commerce team was nominated by Gao Lu, and in just 2 years, the team has built and executed a multi-lab public-private partnership incubator to accelerate technology transfer and commercialization of innovative national lab technologies. Their work has helped position Berkeley Lab at the forefront of the National Lab's commercialization efforts. They paired scientists with business partners, lab resources, training, and a network of mentors and investors. And they helped launch more than 17 startups based on national lab intellectual property. That includes an extremely impressive number. They facilitated 8 industry partnerships, licensed 8 lab technologies, Cradle to Commerce supported ventures that have raised over $10 million in follow-on funding and created 28 new jobs across 7 states, demonstrating economic and workforce impact. Please join me on stage as I call your names. Reshma Singh, Shanshan Lee, Ingrid Java, Vidhi Bhatta, Kelsey Zhang, Banafshe Kabaseno, Yashima Jain, Ruby Barclay, and Laura Wong. The second award in the category goes to the Modelica team, whose nomination was submitted by Caillou Sun. This team created a unique collection of 3,000 validated models to build a library. The team worked with 42 institutes from 16 countries, forming a community of developers and users. The library is now used worldwide to design and operate HVAC equipment, data center energy, and enabling buildings and energy-efficient district energy systems. The Modelica team has enabled researchers, HVAC manufacturers, and data center operators to design innovative products and optimize control and create digital twins, all of which have resulted in significant energy and cost savings. The library is now a leading tool used by manufacturers such as Meta, Trane, and Carrier, and it's used by many federal and state agencies as well. It's no wonder that it's now considered the foundation to a proposed industry standard that digitizes the design and delivery of building control systems. Please join me on your stage as I call your name. Michael Vetter, David Blum, Milicia Grohovitz, Jiangjing Hu, and Ettore Zanetti. Now I'd like to ask Natalie Rowe back to the stage.
Okay, thanks, Marianne. The next category honors excellence in scientific achievement. There are 4 awardees in the category this year. I'll present the first 2. The first was submitted by Thomas Schenkel to recognize the work of the Bella Center 10GeV core team. This team is in the ATAP division, and they're being honored for their work developing a novel technique that allows detailed characterization of the physics of laser propagation and plasma wave generation for the first time. The effort took over a decade, included long nights and weekends in the lab to address multiple technical challenges in the physics and technology of laser plasma accelerators. The Bella team's work could result in smaller and more affordable particle accelerators and represents a significant advancement in the global effort to develop advanced accelerators. And I'd like to invite the members of the team to join me on stage as I call your names: Alex Pixley, Joshua Stackhouse, Carlo Benedetti, Kai Nakamura, Haiyan Sei, Raymond Lee, Carl Schroeder, Jeroen van Tilburg, Eric Essere, Cameron Geddes, and Anthony Gonzalez. All right, the next award goes to the Greta project team. They were nominated by Reiner Crooken. Greta, or the Gamma Ray Energy Tracking Array, is a next-generation instrument designed to study the quantum world of atomic nuclei. Over the course of this 10-year project, the team developed several innovative technical solutions involving mechanics, cryogenics, and detector electronics. These creative solutions were the key to successfully delivering the project on time and on budget. Greta will enable lab scientists to better understand nuclear matter and forces, and it will also be an invaluable asset for the nuclear science community, who will be able to use it at the facility for rare isotope beams at Michigan State. So I'd like to invite the members of the team to join me on stage: Colin Anderson, Jeff Bramble, Eric Bice, Chris Campbell, Heather Crawford, Mario Cromaz, Jennifer Doyle, Paul Fallon, Tin Ho, Eric Puyol, Torsten Stetzelberger, Vamsi Vaitla, and Li Wang. Okay, now I'd like to turn it over to Junko Yano to present the next award.
Thank you, Natalie. So the next awardee in this category is Graham Fleming, nominated by Yan Khan for his pioneering development of two-dimensional electronic spectroscopy, specially applied for photosynthetic systems. So Graham's groundbreaking studies have established an entirely new field, leading to numerous paradigm-shifting results in energy transfer and the importance of coherence in photosynthetic systems. His recent detection of single photon processes using quantum entanglement has significantly advanced the field, enabling new experimental approaches. So Graham's work combines experiment with the cutting-edge theory to understand design principle in light harvesting and energy conversion systems, shedding light on the role of quantum effect in biology. Unfortunately, Graham couldn't join in person today because he's catching a cold. In our email exchange this morning, he sent an apology to everybody that he cannot be here. He was also very worried about what I'm going to say in his absence, but I don't know why. But I appreciate his concern. Yeah. So Graham, thank you for leading our science progress, and please join me in congratulating him on his work. Now I'm turning it over to Jeff Neaton for next awardee.
Okay, well, thank you, Junko. So this next award recognizes two contributors, Emery Chan and Bruce Cohen. They're from the Molecular Foundry. They're also close colleagues and longtime colleagues of mine. Their nomination came from Corey Ralston. So Emery and Bruce invented kind of a cool novel material that massively amplifies an excitation signal by orders of magnitude. And they're calling this avalanching nanoparticles. In addition to inventing this, they also used high throughput robotic synthesis to generate large libraries of these avalanching nanoparticles, which they could then screen for unique properties, changing their composition. So this next step enabled application of this research in huge areas, from nanoscale sensing to imaging to information science and microelectronics. Researchers are now investigating whether these nanoparticles can be used to fabricate optical logic elements for microelectronics, as force sensors within living cells, and as infinite right erase capability, and even probes in deep tissue imaging. So Emery and Bruce's innovative and creative invention has helped raise the visibility of Berkeley Lab on the international stage in materials and chemistry, and generally as a place of scientific discovery. Emery and Bruce, would you join me on the stage to accept your award? Okay, fantastic. So it's my pleasure to present the next award as well. And this one is in community building, and it's going to Dula Parkinson, who is a staff scientist at the Advanced Light Source. So Dula has been instrumental in shaping the culture of the ALS, ensuring everyone feels included and that new ideas are encouraged. Dula was nominated for this award by Anton Vadula. His colleagues have noticed that Dula's extraordinary capacity to foster scientific outreach and community building at the ALS, and his contributions are distinguished not just by their breadth, but also by their impact on the culture and productivity. He's focused a lot on visitors and outreach, doing incredible work with 3D visualization and virtual reality, which is reinvigorate how we communicate to our research to stakeholders, from government officials, including, I think, the Secretary of Energy, to school groups. He represents the ideal of a national laboratory scientist, one who excels not only in research, but in building the community that makes scientific advancement possible. His contributions have created lasting value for the ALS and for the broader scientific enterprise. So Dula, will you join me on stage? Okay, so now I'm going to return the stage to Mike.
Hello again. I learned at this meeting, if I'm ever part of a team award, I'm going to be the person who stays in my office and comes on so I can look over from the top. It's much better gig. So thank you, Jeff. And I will say I've seen Dula in action, and as far as community building, he's something to look up to for all of us. So as we close out, I want to thank the people who have been involved in this, and there are a lot of people, all the nominators who took the time and effort to put together awards materials for the individuals. And please think about who should be here next year. This is the time to think about who you should nominate. I also want to acknowledge that none of us could be successful without the support of our family and friends. So I'd like to actually have a round of applause for all the family who are here, for the people who they brought here. So yeah, and this ceremony could not be done without the support of many people throughout the lab, and many of the people that you have running around and making this all work today. The Career Pathways Group, our IT experts, strategic communication teams, the Security and Emergency Services team, the Creative Services team, my staff in the directorate. And I want to call out Justin Placentia, who did a lot of planning for this event, but is not here today because he and his wife welcomed their first child this morning. So, and breaking news, it's a boy. So finally, thanks to our online audience, we had 141 at the moment, and all those nice little emojis that we have rising up. That adds a lot. It's a pleasure to be here with this full crowd. This is a wonderful group. It's, I think, the 10th of one of these I've done, either in person or online, and it's one of the best days for me at this laboratory to see what great things we do together. So please, let's continue our celebration over at the Integrative Genomics building for reception. Thank you very much.